What if a single machine could do the two jobs that tunnelers have always kept separate: bore through soft ground and blast through solid rock? China just built it. It's called Xianglong, the Lucky Dragon, and it's the world's first boring and blasting machine. Here's the problem it solves. When engineers dig a long tunnel, the rock and soil underneath them are never the same. One stretch is soft clay, the next is hard granite. A tunnel boring machine, or TBM, is brilliant at the soft stuff. A giant spinning cutterhead grinds it away, and the machine lays concrete tunnel walls behind it. But hit hard rock, and a TBM slows to a crawl. The traditional fix is drilling and blasting. Humans drill holes into the rock face, pack them with explosives, and blow it apart. Fast on rock, but useless on soft soil, and the blast leaves a rough, jagged tunnel. So you usually have to switch methods mid-tunnel. That means stopping, pulling out one machine, hauling in another, and losing weeks. Xianglong ends that. Built by China Railway Science and Industry Group in Wuhan and Tsinghua University, it's 15 feet wide and looks like a normal TBM. The difference is in the cutterhead. A normal cutterhead is solid. Xianglong's has a hollow point in the center that can pull back from the rock face with specialized access channels running through the machine. When the geology is soft, it bores like any TBM. When it hits hard rock too hard to grind, the cutterhead pulls back. Through those hollow channels, integrated drilling equipment bores holes several meters deep into the rock face. Workers pack those holes with a special low-yield, high-velocity explosive and seal them with sand or clay. Then they detonate. Now, you'd expect an explosion inside a tunnel to throw debris and wreck the machinery. That's the clever part. These explosives are engineered to create microfractures in the rock, hairline cracks that weaken it, without launching chunks or creating a massive shockwave. Whatever force is generated gets deflected and absorbed by the machine's protective shield, which sits between the blast and the sensitive electronics and motors behind it. Once the rock is fractured, the cutterhead slides back into position and sweeps over the now softened stone, crushing and removing it as if it were ordinary soil. Bore, blast, repeat. The whole cycle happens inside one machine in one pass. According to Chinese state media, that makes Xianglong about 30% more efficient than a conventional boring machine in mixed ground. The shield can even vary its diameter to accommodate different lining segments, so the tunnel walls stay consistent even as the rock changes around it. Why does this matter? Because the world is digging tunnels at a staggering pace. China alone has produced over 4,000 tunnel boring machines, about 70% of the global market, boring under rivers, through mountains, and beneath cities for subways, high-speed rail, and water projects spanning 100 miles. The harder and more mixed the geology, the more a machine like this saves. Weeks of downtime become hours. There's a bigger story here. Tunneling moves slowly for decades, then leaps. For 200 years, drill and blast barely changed. Then, the TBM revolutionized soft ground tunneling. Xianglong is the next leap, one tool that reads the rock and switches tactics on the fly. One day, machines like this won't need operators to decide when to bore and when to blast. Sensors will read the geology, and the machine will choose for itself, second by second, adjusting explosives and cutter pressure in real time. The tunnel will dig itself. For now, Xianglong is the proof of concept that the two oldest tunneling methods can finally share one body. A boring machine that isn't afraid to blow things up. Subscribe to The Rowdy Times for weekly engineering and technology explained without the fluff.